So the other new product or thing that I did that I want to talk to you about, I've been working on basically all year, and I kind of became inspired to do after the last KansasFest, not because of anything in particular that, and the last KansasFest was my first KansasFest, and it was not because of anything in particular that the last KansasFest made me think about at any of the sessions or whatnot, but it certainly did get me re-inspired about the Apple II. I had only started using it again after many, many years. Then I went to KansasFest, and I was pretty jazzed, and I started to think, well, what's a project that I can work on, you know, to kind of get back in? And there was a program that I wrote back in, what, 1994, and you know, before I was rich enough to make Kansas City my summer location, and so in 1994, I wrote this utility, and it always had a bug, and it bothered me, and I thought, well, it would be good to kind of pull that out and maybe like fix the bug, you know, 50 years later. And I started to work with it, and I started to be like, oh my God, this is horrible. I like program in Java, and I program in AppleScript, and I program in PHP, and it's like, typing in things into Applesoft was like making me insane. I couldn't organize anything in my head, just my style of programming had changed substantially, and that actually was the germination of what led to the structured Applesoft articles I wrote in juice.js, because I started thinking about, well, how can I write Applesoft programs like, like the ones, you know, in the style of programming that I'm accustomed to. And so that meant, for those of you who you know, might have skipped the articles, or didn't see them, there's basically the idea, and I'll show you this, is that I actually don't write my programs at the Applesoft prompt at all, and instead I write them in an editor. I write it in BBEdit. I wrote a syntax colorization module for BBEdit, so everything looks beautiful, and I'll show you what that looks like in a minute. And then I basically devised a bunch of sort of self-imposed rules, and that's what's documented in those two articles, about how to write a program. So, anyway, I'm getting a little far afield here, but getting back to one of the things I wanted to do as part of writing structured programming is I wanted to be able to call a subroutine by a name or a label. So, and as opposed to a line number, because line numbers are just like really inflexible. I just want to think like, I just want to give something a name, like checkit file exists, and be able to call that thing and have it do it and come back and not think about whether it's at line 45816. And so I started a project called Magic GoSub, which is at this point long unfinished. I've kind of just kept iterating down into the well. Maybe I'll iterate back up and get all the way back up to Magic GoSub and then up to the program that I originally wanted to fix the bug in. But what happened was that I wanted to exploit something I found in Applesoft, which is that if you GoSub to anything that's not a legal line number, it in fact GoSubs to 0. So that gave me an opportunity to, with a little machine language magic, to kind of figure out a label and hopefully go where I wanted to go. So that was all well and good. But then I got to thinking, well, that kind of sucks though, because that means that I need some machine language every time I want any of my programs to run. I need to reload something, and that's lame. So I didn't want the dependency of another file that would have to go along with the program. And so basically I looked into, well, are there any ways of getting machine language into an Applesoft program so you don't have that dependency? So as I said, so basically there's 5 methods that I either knew about or were suggested to me. There's vload. It's fine, you know what it does. It requires another file. I didn't want that. There's data, and then read bytes out of data statements and then poke them in. That really sucks because it's hugely wasteful of memory, it's hugely slow, and furthermore, all the numbers are in decimal, and so it's just hugely unmaintainable. You have no idea what you're looking at when you're looking at a bunch of data statements. And so, sorry, train of thought issues. And so so that was method number 2 is data. That's not wasn't very good. Okay, then there are a couple of tricks you could deploy. You could like have a rem statement and then actually fill that rem statement with binary data, which theoretically your program hops around. But the problem is that then when you list your program, you see a bunch of crap in the program listing. I'm sure you've seen that from time to time when illegal Applesoft data, either intentionally or otherwise, sneaks its way into where your program should be. And also then, if you edit a program like that, there's just no guarantees that it's not going to destabilize, that it's going to run, that the machine language will move where you want it to, etc. Okay, a similar trick, which has similar kinds of problems, is to stick your machine language at the end of your, Applesoft program, but before variables begin. So that's a cool trick if you want to just have an assembled program. You can save the program that way. It will load and save with your machine language program hidden tucked away at the end of it. But, big but, again, if you edit the program, if a user edits the program, it's basic, it's made to be edited. You're going to eat your machine language program. Nothing is going to work anymore. Okay. So basically, all the solutions that I saw were either required dependency, slow, brittle, or any combination of the above. Then I discovered, or rediscovered, a cool technique that I remember seeing from long ago in the Apple II, which was called the SH-LAM technique. Is anybody familiar with that? Pretty cool, right? That was, so anyway, this guy, Neil Parker, who has a web page where he discusses the SH-LAM technique and in fact discusses fixes to it. So basically what the LAM technique did is it allows you to stick some machine language like you would enter at the monitor prompt into a string and then poke those characters into the input buffer, the same place where you would type characters, like when you type, list, it's typing L-I-S-T into 201, 202, 203, 204 in memory. Or, I'm sorry, into 200 through 203. And anyway, so this fairly genius trick will poke the characters of that string into there and then call a magic call, which is in fact the portion of the monitor ROM that interprets what you just typed when you're in machine language. So in other words, it was kind of a brilliant hack where you basically tricked machine language into thinking that you were in it and something was just typed into it and it should process what you just typed. Anyway, so I'm like, oh yeah, that's real cool. And then, but it has some compatibility issues. It can leave the stack screwed up. It didn't work on 2GSs, etc. So further on this page, it was documented how to fix all that so that it actually can be solid and works across a variety of Apple IIs. So that struck me as the best option because I like that you could at least have the flexibility of actual machine code in there. But problems with this too. Still slow. You've got to pick apart a string character by character. If you're dealing with anything of any length at all, it's slow. So, and I thought to myself, well, crap, there's no good solution. What I want this, but I want it fast, and I want it without deloading. And that's what I want, and I have to have it. So how the hell is I going to do that? Because it seems like an impossibility. And thus began what I would say was my own personal programming climbing Mount Everest. I thought to myself, what if, actually before I even tell you how I did it, let me just show you what it does, because it's cooler that way. Here we're done with new input. What we're not done with is Slammer. Alright, so here we go. Let's just write some machine language, shall we? Let's put it in rem statements. Rem. What should we do? Anyone want to do something in machine language? Let's just stick a byte on the screen. Let's stick a letter in the lower corner. Let's make it a K for KFest. That's easily done because we can just store what we type in machine language. We type 7F7. What's a K? It's a CD. Right? Well, we'll find out. Oh look, so I typed a single line of code. Let's see if anything happens. Ta-da! I just typed some raw machine language into Applesoft and it just interpreted it. And likewise, then you can type in a whole routine. So you could go, let's put something into 300, and let's say A9, C9, that's load I, and let's, I don't know, I'm not very imaginative, let's dump it out in hex. Let's have it just print C9 in hex. If anybody has some like cool things they want to see in machine language from Applesoft, shout them out, because I'm feeling imagination impaired at the moment. Alright, so we can do that. But actually, we can break it up, just like you can in machine language. And not only can we break it up just like you can in machine language, just like you can in machine language, you don't even need to specify another address. This is just the same way you would type in the monitor prompt. So now let's go to the routine that spits out a hex byte, and I realize you can put this all in one line, but let's do it this way. And then return. Oh, actually, it's unclear what all this does. So how about we add a comment to it? You can, in Slimer, comments on the end of your thing, or whatever Apple calls it. All that's perfectly legal. Everything from the semicolon onward will be ignored. And when we type run, nothing happens. Why does nothing happen? Because all it did was stick it in 300. But you'll notice that it types out the 68 now. It spits out a C9. So, by doing this, you can in fact embed a bare-sized routine into your Applesoft program, and I've provided a utility so that you don't need to type in the bytes yourself, but it will in fact just take a routine that you've already got stored on disk or sitting in memory and convert it into these monitor command lines. You can also do some fancy tricks. So, for example, let's get rid of these. Any questions so far, by the way? Yes, sir.
This program Slimer, this is the same one that relocates itself up into the lower memory, you're saying?
No. I'll explain all the ins and outs of it. Before we were talking about new input, and new input doesn't relocate itself.
So where does this program here reside as your program?
I will show you that.
Okay.
That's where the magic really lies. Now you're saying that the program that facilitates my being able to do this.
Right.
Yes, I'll show you. But first, let's enjoy some smoke and mirrors a little bit longer. All right, so we can also do some fun tricks like this. Like, how about we want to turn the high-res screen blue, and we don't even want the user to see it. We can go 2000 D5AA, that happens by coincidence to be the bytes for high-res blue. And then we can take advantage of the bizarre memory move thing where you can actually wipe out a block of bytes repeatedly. This is a technique often used for clearing out memory. It's apparently a bug, but I find that functional. What can I say? Oops. So right now I'm actually performing a memory move right from my Applesoft program, no problem. And then we could do some pokes and peeks from BASIC, but we're already processing monitor commands. So let's do C057 to turn on high-res graphics. Now, someone might say, oh, but you can read from those rather than write to them. The reason why I don't want to do that is because when you read from them, it will spit text back at you. I don't want that to happen in my program. So if you write to them, that doesn't happen. We can separate multiple monitor commands just as you can at the monitor prompt with N. N, for those of you unfamiliar with it, stands for normal text. It's another monitor command. It's often used just as a spacer since you rarely want inverse text within the monitor. But N provides a way of joining multiple statements. So let's do that, and then let's also turn on graphics. And let's see what happens. High-res blue screen. Yay. Would you prefer orange, sir? So that is how you, I'll show you the utility in a minute that makes a lot of this even easier for you. But that's the general gist of, without even needing to know how it works. Oh, in order to kick it off, there's one more line that you need to see. Call 2107. What's a 2107? 2107 is, and I'll show you the details of it, but it is the code that tells it to start processing monitor lines. It will continue to process REM statements until it either hits the end of the program, or a REM statement with nothing in it, or a statement that isn't a REM statement. Therefore, the one thing you should not have before one of those three things happen is a REM statement that's a general comment, because it will try to be processed by machine language, it will be treated as junk, and you will be thrown into the monitor prompt immediately when the program is stopped. Anyway, so if we go, all right, so that's basically it. You start anything off with call 2107, and then 100 through, and then your REM statements follow until a blank REM, no REM at all, or the end of the program. And so, all right, your curiosity is about to be satisfied.
So a blank REM will throw it back into
Yep,
Applesoft.
that's right. So we can do this. Blank REM. Now we can have an ordinary REM. Now, you don't have to do a blank REM to go back to Applesoft. You can just do regular Applesoft and it'll see, oh, that's not a REM, I'm back to
But this allows you to put REM statements in without the...
Right, this allows you to get a REM statement in immediately after your monitor lines. That's basically, it's probably its main purpose, or just as a matter of style. You could just visually choose to terminate it with a blank REM. You know, so...
Then you could call it again later in the program.
Absolutely. You can call it as many times as you like. Nothing gets modified or anything like that. Now, in many cases, what you're just going to be doing is you're going to call once, because what you're going to want to be doing is just installing bytes somewhere in memory. Once those bytes are in memory, you're going to want to call them and not reinstall them, so to speak. Okay, so yes, so that would make something like this still work and not crap out. Okay, you also, of course, have the option, if you want to comment immediately after, is you can just go REM and then just start a semicolon, and you don't have to have a monitor instruction at all. Just stick a comment right there. Okay, so here, let's look behind the curtain a little bit. What makes this work is what?
Pixie dust.
Yes, pixie dust, and a little bit of RAM. A specialized line 0 through 9. What's in line 0 through 9? Let's have a look. That. Now, that might look like, I thought you didn't want crap in your Applesoft program. But in fact, technically speaking, it's not crap. It's legal typable ASCII, such as you would be able to type on an Apple II Plus keyboard. There are no, if you were a very tenacious robot, you could type in all of those letters exactly, and this would work. If you want me to prove that point, I can copy and paste it into the end. So let's look at it again. In high res, what easier to see. Still, a bunch of ASCII crud. So, basically, this was the Herculean challenge that I undertook, which was to basically write a program that would enable me to process monitor lines like I showed you, using only what are under the hood, using legal typable ASCII characters, thereby making it legal Applesoft, and each character under the hood corresponds to a machine language opcode or operand. And so, what that means is that I wrote an entire machine language program using only bytes from 21 to 5A. For those of you who don't program in machine language, that would be probably equivalent to writing a novel with only the letters C through K. Which is to say, you'd have to be insane to do it, but there's the because it's there factor, and there's the fact that I just really, really, really wanted it, and I did not want to take no for an answer. So now we're starting to get out of the how you use it and more into the how I did it. There is a utility I can show you. So would you rather see the rest of the how you use it before I get into how I did it, or would you prefer to know how I did it?
I'd like to see you enter the monitor and type 800 list.
Okay, it will make your eyes bleed. Ready? Ready for some fun? Here, do you want an 800 list? Have it your way. This is what it looks like. You will notice vast amounts of repeating patterns. It's basically impossible to read. It's incredibly inefficient,
But it really works.
but it really works, and it accomplishes its goal. For the cost of a little bit over 2K, you get all the machine language you want right in your Applesoft program, as only limited by memory, which is considerable because we'll get into that in a minute. But
Real trick making all the rolled and branches be in that, the displacements in that range.
well, I'll show you. Let's have a fun since we've gone there. Well, as I said before, I continue. Do you want to see more of the utility and how you can use it to make your life easier, or do you want to see more of the how I did?
What's the utility? Only because that way we
Okay, let's do it. We'll come back to how I did.
start gently and then blow our minds.
Fair enough. All right, fine. So that gives you the rough overview. Yes. So to answer your question, the code that does this is literally the start of your Applesoft program. The start of your Applesoft program is REM statements, legal REM statements, typable REM statements that are the code that performs the magic.
And by typable, you mean you could have theoretically read this out of a full magazine and plugged it in your...
Well, in fact, that was my original idea before I realized just how many bytes it was going to take. I loved the idea of it being something that you could type it in out of a magazine. That's obviously, you'd be insane. But you could. In fact, you know what? Just because now you've taunted me, I feel like proving the point. So let's...
I typed in a lot of crazy things for magazines.
Fair enough, but did you ever type hundreds upon hundreds of ASCII characters in no particular sense? Maybe not, but you could have. All right, so whoops, I didn't use one quote. Oh, I forgot. Thank you so much. All right, these are the lines all by themselves. They live in BBEdit. Right now, they're a text file. You'll see that do not modify lines 0 through 9 is an integral part of it. You can't modify any of this, or the whole thing will break. And if you were to quote-unquote type it in or paste it in, as I'm about to do, it has to be exactly as you see with one space on either side of the red, or it will not work. If you list it and then right arrow over it, it will break it because list adds a space on the other side of the red. So let's go back to Virtual 2. I just started up a brand new virtual machine. It's, bare metal Apple II, no DOS, no nothing. Let's go paste. Oh, you're not pasting full screen. All right, paste. All right, I just typed in a bunch of stuff, really fun. And then let's go 10, call 2107, 20, let's just clear the screen just for yucks. I realized I could type home, but what the hell? What?
Get a random there.
Thank you. Anyone want me to do something more snazzy? All right, fine. There we go. All right. And I don't need to type anything else. It's the end of the program. It knows the end of the program means to stop doing things. Done. So so you can see that basically it's all Applesoft you could type in. In order to make that possible, it means that every letter, every number that it corresponds to under the hood has to correspond to a machine language instruction. I have to work only from within that set. But we're getting far afield because we wanted to see how it goes, and then I will go back into more of the how I do, which is anyway. So where was I? Oh yeah, let's look at Slammer utility, or what's it called? Slaminator. It's called Slaminator. Thank you very much. What is currently in the emulator disk drive is the same as the disks that you will be receiving today, should you want one. There it is. Let's run Slaminator. And actually, do you want to see it at full speed for the sake of time, or do you want to see it at like real 100% speed for the sake of authenticity? Okay. You can see more program, but you're not going to need Slaminator. Okay, so while it loads, I'll tell you what it does. Slaminator allows you to load a routine from disk and just turn it into those monitor command lines that you saw in that we started to type in ourselves, rather than having to type it in yourselves or capture or modify a hex dump. You can just do it with Slaminator. There are also all the documentation on how to use slammers here in Slaminator help. This is everything that I've told you already, so I won't read it through, but there it is. This will tell you what to do. And tells you what not to do. And you can also, two quickie commands in it is, you can just start using Slammer by loading a program that consists of just lines 0 through 9, and then you get to work. You can also just choose to from this menu, and you're dropped into an environment where lines 0 through 9. Okay, now then, the problem with having done that is now we have to run Slaminator, so let's not do that again.
It's not
Yes, it works
You
just
have
fine.
a typo in your thing. It says use Lammer.
That is not a typo.
Secondary thing.
That is not a typo. So one thing I
There's two
haven't.
difference, okay.
Okay, there is a difference. The marketing department decided for clever rather than clear, and so Lammer. The name originally was Lammer, named after the SH-LAM technique, because actually the Lammer command processing uses just a much more sophisticated version, not even a more sophisticated version, just a more featured version of what was laid out on that web page that I showed you that was discovered by SH-LAM, like back, I think, in the days of cassette. And anyway, so I wanted to name my routine after him, so I called it Lammer. You do have the option of not using those magical lines 0 through 9. You can just beload Lammer. It's relocatable. It fits at 300, so that's a nice place to put it. And then you don't need, if you don't like those lines at the beginning of your program, you can beload Lammer and then call it instead of call 2107, and then follow with the same amount of command lines, and it will work just dandy. I don't think it's as cool, because then you have to beload something which partially defeats the purpose, although it still has some benefits, because it would still allow you to embed multiple routines in a program rather than having to beload individual routines. It would allow you to visually see the routines within your program if you think that's a benefit, and or edit them, etc. Also, they don't even have to be routines. It can be data. It can be whatever, of course. All right. So anyway, if I chose number 3, what it would do is it would do the exact same thing I just showed you, except it would give you no program, and Lammer would just be sitting at 300, where you could start to use it, or you could save it, or you could move it to somewhere else and use it from there. That clear what I just explained, more or less? Okay. All right, so here, let's walk through. So otherwise, the main thing that Slaminator does is it gives you a wizard. So it's going to ask you a bunch of questions designed to help you get your routine to monitor command lines. So, your routine can be preloaded in memory. If so, it needs to be at 7,000. If you choose to have it beload a routine, as we're going to have it do, it's going to put it at 7,000. You should not, if you use a routine that's larger than 4K, I guess, it's going to start overwriting things and things will barf. You should not be encoding routines larger than 4K in this way. You should be beloading, because what's going to happen is, I'll show you, but basically what happens is whatever routine you encode is going to take up memory times 4 of what it normally would. Because 1 for the space it occupies in memory, and then times 3 for all the visual bytes that appear in your Applesoft program. All right, moving on. No, we do not have it loaded. What's the name of the routine? Lammer is already saved to disk. Let's use it as the basis for our routine. So, here it is the routine relocatable? It so happens that Lammer is relocatable. Now you're heavily incentivized to write relocatable code when dealing, because there's a very special feature that Lammer offers, or Lammer, which is that you get the option of storing a routine between the end of the program and the beginning of variable space, and it figures that out for you automatically. So it's not saved in your program, it dynamically, when it starts processing your code, it starts putting lines right at the end of your program. And you indicate that, I will show you, by using 4 asterisks instead of a machine language address where bytes are intended to go. So in this case, let's say, yeah, I do want to store it here. For the length of your routine, if you deloaded it, it will pre-fill that for you thanks to new input. All of this is using new input. I wrote new input to support this program, basically. 182 is correct, so I can submit a return. Do you want to include Slammer? So this gets to your question. You can either get the line 0 through 9 version, or you can get the beload version. If you get the beload version, then you have to make sure Lammer's on the disk. We are going to say yes, we want to include Slammer. What line number do you want your monitor command lines to start from? I like to stick them way up high out of the way, so let's say 64. 1000. How many bytes should appear in each monitor command line? This is a matter of preference and style. I like 64 because then it just takes up a little bit less memory and it's just less overhead. But for the sake of looking to see what it's doing, let's say 16. And finally, now currently I will fix this. This question is only available in DOS 3.3 and not ProDOS. Do you want to save your monitor command lines as a text file so then you can exec them into an existing program already? So that way I thought, well, you could save it as an Applesoft program, but then if you got an Applesoft program, then you load it, it overwrites it. What if you could just exec into a program that already exists, and so you get that capability? I'm gonna say no. All right, your slam routine is now ready. You can list it or save it, or call 252 now for an unformatted listing. There's no real reason for that, except that I use it for writing out the text file because, as I said, the spacing needs to be just so. So, you know, I can show you what that looks like. Anyway, now you've got a note here that says, when run, your program will be placed between the program end and the variables, which also I forgot to mention, if you do it that way, it erases any already set. So you really want to, if you choose the option to stick your code between program end and variable start, you should do it before the variables are set. And then you would call that kind of routine, since you don't know what address it's going to be living at. You've got to calculate peak 175 plus peak 176 times 256, and to call your routine once it's installed. Because that is what those numbers are. Is that's where Applesoft stores the location of the address after the end of your program. All right, let's take a look at the list. That should look familiar. Lines 0 through 9, and then there's our routine. And so now, we do not need to reload that routine. It's available to us. And so what you would do is you'd probably, up early in the program, you could, let's make this into a subroutine, shall we? So I should have probably started a little later, but let's go 59,000, or 59,999. Oh no, we can just, sorry, it's the structure. But 60020, return, and then from 10, I can just go sub 60,000, RAM, install, normal. I mean, it's a little redundant for me to install Lambda because I'm using Lambda, but it just happens to be the routine that was sitting on the desk. It's obviously your routine, it's not yours. Here, let's just to clarify that. Make it install routine, and then now once that's done, it's ready for use. You can then call your, as I said, to call that routine, you've got to do it at that particular peak. Otherwise, if you didn't have the 4 asterisks, that would specify a machine language address, and you would just call it at the decimal version of that address. That all clear? Clear enough? Any questions? All right, so that's using it. I mean, I could go over each version, you know, exactly all what the questions in the wizard do. They just give you different options about, do you want to, it didn't ask us to use the 4 stars, but like it'll give you an option to list the addresses on every line if you start with a known address, or keep it spaces like this just for format. You know, so it allows you to kind of customize it to sort of your own tastes and needs. And but you're probably better off just playing with it and to get a sense of what it does than having to walk through every bit of it, unless you specifically want to see other features in it. Okay. All right. So now. That's Slammer. That's how it works. It's either special line 0 through 9, or it's reloadable. Reloadable is still pretty cool, but it's not quite as magical as the line 0 through 9, in my opinion, which allows you to have machine language and self-contained Applesoft. So now we get back to the how I did it. Is everyone ready for me to go back there? Okay, let's go there. All right, so oh man. Up here. All right, so basically, let me show you something. This will probably only really make sense to the machine language persons among you, but oops, it's a little too big. Smaller. That'll do the job. All right, you know what that is? only opcodes I was allowed to use.
Huh?
You know what it's like writing a program without load, without store, without x, without y, without JSR? With jump being useless because the only place that you can jump to is somewhere between 2020 and 5A, 5A? It's a problem. So I had to be resourceful, to say the least. So what I started to do was, I was like, well, how can I do this? Like, okay, like I need to load a byte. How do I load a byte? So what I figured out was, for example, there are several of these kinds of patterns, that if you LSR something 8 times, guess what? Or you LSR the accumulator 8 times, you have a 0 in the accumulator. Well, okay, a 0 is a nice place to start from. If you EOR against a 0, then you've effectively loaded the accumulator with the operand of the EOR.
Because you don't have LDA.
Because you don't have LDA, or LDX, or LDY. You don't have LD anything. So it was figuring out things like that. How can I? So then there was another question of, okay, but how do I load some other value beyond, what EOR, I can still, the operand can still be only 21 through 5A. So, therefore, what am I gonna do then? So then I figured, well, if I set the carry and then roll it, in the right direction, then the carry can kind of go into a byte. And if I set the carry the right way, the right number of times, then I can roll it 8 times. I can actually, through a sequence of carry setting and shifting and whatnot, get a byte to what I want. But trying to code like this makes you want to kill yourself, is what I discovered. And so what I had to do was I realized that I needed to be able to write something like LDA once and have that magically expand into the 24 bytes or whatever it is that it needs to be. So how are they going to do that? What I did was I sought out an assembler that I could hack rather than use an Apple II assembler. Because if I use an Apple II assembler, for one, I prefer to actually do the edit in a Mac editor and then paste a thing anyway. I didn't even get to show you much of that, but anyway. But I'll show you now the way I did it. So here, let's look. This is the source code for Slammer. Let's indicate that this is 6502 assembly. I wrote a little 6502 module for text wrangler and BB edit, so syntax colors. Anyway, so I made a bunch of my own opcodes, LRA, LQA, SRA, SQA, and I was able to do this. You're like, what the hell's that kind of assembly? So I found on the web, this website, 6502asm.com, which has an online GPL 6502 assembler in JavaScript. It was completely buggy, not Apple II specific, whatever, but it was an assembler for free in JavaScript, which meant that I could very easily go over the hood and make it do whatever the hell I needed it to do, which in this case meant expanding my own opcodes into magical patterns of my own devising so that things could only go. So basically, I would then take this code, Command A, Command V, assemble, and get a byte dump out of this assembler. You will see the Apple II specific stuff that allows me to just copy and paste this into Virtual 2 because I did it. It was JavaScript, nothing to it. And so anyway, so there were some really significant challenges. So basically, how am I going to store an arbitrary byte to an arbitrary location? What I had to do was, and the first 2 lines, lines 0 and 1, are responsible for this. What I had to do was create a short routine at 3A through 4.5, which are all temporary locations in machine language available for temporary use. and create a little store routine, and so then I could hack at it. So, so then there was something up there, and then in my code I can actually then, stick values into here as needed to be able to store bytes. It takes what? I think 70 bytes to store a single arbitrary value into an arbitrary byte. STA becomes 70 bytes. So I can go into all the details of all of this, which would really thrill me because I feel so incredibly clever, but it would probably bore a lot of you. Let's just say that it was a challenge, and one that I feel virtuous for having met. It, and I even noted here, yeah. So you can see it takes 70 bytes to store for a store STA. Because there's no jump, the only way I could get from place to place was via the RTI command. So I had to push stuff onto the stack. Like, how often do you ever use RTI? The answer is, except for you, maybe never. And so I pushed the right 3 bytes on, loaded them into the computer laboriously. Fortunately, I had PHA, right? Without PHA, I would have been dead. It was amazing because it's kind of like, this was just the bare minimum of stuff. I think I used every single one of these except for jump accumulator. I mean jump address. And it was just, CLI I used as a NOP, which has a placeholder of things that I then have to go and change. So anyway, so what happens, to make a long story short, line 0 through 1 just sticks something up in 0 page, and that's a typical short store routine. Lines 2 through 5 are just responsible for patching numbers in values in line 6. Once line 6 is patched, it does the actual decoding of the Lambda routine, which is hidden in line 7 and 8. Where does it expand into? Into line 9. Therefore, it's actually possible, I haven't completed the utility for doing it yet, but it's also possible to actually stick something other than Lambda in line 7 and 8, and as long as it's a short routine, and deploy it as you like. So that's the very short form of how I did it, and how we now have a way of sticking machine language commands, byte entry, memory moves. Hell, you can do a cassette read if you want to, right into an Applesoft program. And I'm really delighted to be able to both have been inspired to do it by KansasFest, perhaps sort of with the motivation that I get to come back here and present it. I finished probably with, I don't know, maybe 3 minutes to spare. I've hardly enjoyed anything here because I have been, when I'm not in sessions, I've been coding. I'm just kidding, it had to be a great time. But I got the photo finished, and I have the discs available for you, for those of you who want to play with it. And thank you all very much for your interest, or at least attention. Are there any questions?
Were you talking about this on the KansasFest groups?
You know what? I mentioned it way back in September. I first was talking it out loud. I was saying, how do you get the original problem? I'm like, what are the solutions? And that was how I realized that there are these 5 solutions I don't like. And then I think one of the Brutal Deluxe guys, I think Antoine, was kind of like, you can do this. And I'm like, I wonder if it's possible to actually just have legal stuff up at the beginning of your program that can do this.
Because I think that was a conversation I tried to jump into, but at that particular time, 82 Central wasn't forwarding messages onto the news group.
Got it.
So the one
what would you have said?
Suggesting using base 64 and wrote a routine that would decode base 64.
And indeed, that is roughly what I did.
But your lines 0 through 9 there could be replaced with a base 64 decoder with just strings.
No, they couldn't. How would you do that and write it using only opcodes line 21 through 5A?
Well, it wouldn't be assembly language. It would be actual Applesoft that decodes the
that would be slower than hell.
But then you would just have a string with your routine that gets converted into.
And it would be slow. I mean, for that, yes, that could work if there were no other solution. But I think, like the SH-LAM technique, which is sort of, something roughly similar, it would still be slow. I think. Anyway, yes, that would have been a solution to use Applesoft to decode something in base 64 embedded in Applesoft, which could then be responsible for more monitor entry. That might have been okay. There would have been some pause, but I'm want something even faster.
Alternatively, you could use the data statement approach to poke in a short machine language program.
I could have done that, but I did some timing tests, and it's like, if you want to poke in 200 bytes of data statements, it takes measurable seconds of time.
No, you missed what I said. You poke in the base64 decoder, very short, constant, fixed, bam, boom, you do all the thing in base64.
Yeah, I get the
And
code.
that winds up
Just
saving
like how
some space.
the Lammer code you said fits in line.
Lammer code is 192 bytes.
Yeah, so to decode 186 base 64 characters, or would it come out to 200?
Right.
In Applesoft, just to be
Yeah, and you could go climb Mount Shasta, but would you rather go that way?
That's that one.
Yeah. It's very cool. I really appreciate the irony of you're presenting highly structured Applesoft and absolutely infinite spaghetti assembly.
Yes. I think infinite spaghetti probably is the right term. It is. Once you look at the end product, absolutely. But the assembly code that actually makes it, that I wrote, I can show you. It's my own magical opcodes, but within that world, it's actually relatively orderable.
Yeah.
It's something.
It's easy for streaming those path because I'm in exchange emails a lot, and I'm crazy about the Apple II Plus, of course, which doesn't have lowercase. If he'd allowed himself lowercase, he would have a whole bunch more options.
As I would have if I'd had 65 CO2. Actually, what I would have had if I had lowercase, because I looked, I would have had, I think, ROR, in addition to ASL and ROL, and ADC. Both of those things might potentially have been useful. They wouldn't have been revolutionary, but they might have helped. But it wouldn't have been like having LDA. All right, well, thanks.
cool.
Oh, does anyone want some floppies?
Yeah.
3.5 and 5 1/4. Well, I've only got 5 of the 3.5s. So those who need one, I mean, I can make more. I thought it was more fun that way. All right, 3.5 it is.
Remarkable.
That's pretty impressive. Sure.
So, Ivan, when do you start therapy?
This was my therapy. What do you mean? This was catharsis. There you go. Anyone else? 5 1/4? 3.5?
Whichever one you want to get rid of, I got those ready.
All right. Well, I got 4 of each left. All right. All right. 3.5 it is. If any of these were made in a bit of a hurry, call the customer service department for a possible replacement if there are issues. Yeah. No, I don't have 3 1/4. I do have 3.5.
You got 8?
You're tired.
Just buy off the extra quarter inch.
You're welcome, sir.
3 1/4 is the dimensional lumber.
That's right. Print shop.
My whip, that's happy.